Okay, students, today's lesson is on parabolas, and I'm going to combine together the type of parabolas that open up and down and the parabolas that open left to right. So first, looking at the parabolas that open up and down, if you remember from the very first lesson, the standard form for our parabolas that open up and down are x minus h quantity squared equals 4p parentheses y minus k, close your parentheses. So what you need to recognize is that a parabola is going to open up and down if the y variable is the one that is not being squared. Now you can have two types of parabolas that are vertical. You can have one that's opening up. This is the blue parabola is the one that is opening up. Notice that your vertex is going to be represented by the h comma k, the ordered pair hk. And you will know that the parabola is going to open up if the 4p, and again the 4p is just some number, okay? It's just some number, any number. But if that number is positive, then it's going to open up. If the 4p is negative, then it's going to open down, okay? Now, vice versa, if you have a parabola that is opening left and right, the standard form equation is y minus k quantity squared equals 4p times x minus h. And again, 4p is just some number. But if that number, 4p, is negative, then it's going to be opening to the left. And if 4p is positive, then it is going to be opening up to the right. All right, so let's look and see how we're going to graph these when they're written in standard form. Here's our first example. We have x squared equals a half y. So what you want to do in the very beginning is, if it is already written in standard form, which it is, there's a couple of things that I want you to recognize. First of all, I want you to tell me, is it opening up, down, left, or right? Well, because the y value is the one that's not being squared, then we know it's either opening up or down. Well, because the 1/2 is positive, then this would be opening up. The other thing that I want you to get from the standard form is the vertex. Well, remember, the vertex is with the x and y, and since I have no number that's being with those, then my vertex is just 0, 0. Okay, in order to get a good picture of how we're going to graph this, what you want to do is you want to get the y value by itself on the left-hand side. So if you're writing down some steps, that's the first thing you're going to do, is to get the non-squared variable by itself. On the left. Okay, so we're just going to completely rearrange this equation. We're going to take this, we're going to move it over here, and we're going to take this and move it over here. So when we rearrange it, we're going to have 1/2 y equals x squared. We don't have to worry about changing the signs because we're moving both of them. If you're moving both of them, then you can keep the signs exactly the same. Because again, it would be associative. All right, so we want to get the y by itself. Well, in order to get rid of a fraction, we have to multiply by the reciprocal. Well, the reciprocal of 1/2 would be 2 over 1. So we're going to multiply both sides by 2 over 1. So on this, we get this canceled out, and so that would give us y equals 2. We're going to put that in front of the x squared, so it'd be 2x squared. Now we have our y by itself, and this should look familiar to what we worked on when we were working with the parent functions at the beginning of the year. That 2 is a stretch factor. It's stretching all the y values by 2. So in order to graph this, the first thing that you're going to do is you're going to graph the vertex. The vertex is at 0, 0. Now you already know that it opens up, so you can kind of have a general idea of what this looks like. But in order to graph it exactly, we're going to take our 2 points, 2 points on the right side of our parent function. So our parent function points were at 1, 1, and 2, 4. Whoops. Okay, well, if I'm stretching this by 2, you're taking the y values and you're multiplying that by 2. So my new ordered pair would be at 1, 2, and this ordered pair would be at 2, 8. Okay, so let's go ahead and graph those. 1, 2 would be right here. 2, 8 would be off my graph. It's going to be way up here, so I'm not going to graph that one. But remember, we have a symmetrical point on the other side. So on our other side, we're going to have a point right here. And then now I can go ahead and I can draw my parabola. Alright, so this is part of the information that we need. We also want to state the line of symmetry. Well, the line of symmetry would cut the parabola in half, so it would be basically the y-axis. The equation for the y-axis is just x equals 0. And that is our line of symmetry. Alright, so let's look at this next equation. First thing that I should notice is that it is not in standard form. So remember, for a parabola, to get it into standard form, you want the squared term on the left and the non-squared term on the right. So it looks like my y's are the ones that are non-squared, so I need to move that over to the right-hand side. I also need to move my number to the right-hand side and keep my squared terms on the left. So on the left side, I'm going to have x squared minus 12x. And then I am going to have to complete the square, so I'm going to leave a space here, close my parentheses, and put another space because I'm going to have to balance it. And if we're moving the other 2 to the other side, you have to change the sign, so you're going to have negative 4y minus 44. Okay, let's go ahead and complete the square. So to complete the square, I take half of negative 12, which is negative 6. I square it, that gives us 36. Balance it with a minus 36, and now move that minus 36 to the other side, make it a plus 36, and let's write what our new equation would be. It would be x minus 6 quantity squared equals negative 4y. Negative 44 plus 36 is minus 8. And then we need to factor out the coefficient that is in front of the y. So we're going to factor out the negative 4, and that would be y plus 2. Okay, so this right here is my standard form. So that's going to give me some information about the vertex. So I'm going to write my vertex over here. My vertex is the ordered pair 6, negative 2. Okay. The other thing that I will notice is how it's opening, because this value right here, the negative 4, is negative, then it's going to be opening down. And again, you know that it is a vertical parabola because the non-squared term is your y, so you know it's going to either open up or down. And then we'll do our line of symmetry in just a minute. Alright, so from here, now we need to get that y value by itself. Okay, so we're going to completely rearrange this equation and just move this side of the equation over here and this side over here. So we're going to have negative 4 parentheses y plus 2 equals x minus 6 quantity squared. All I did was just rearrange it. Okay, we're going to multiply both sides by the reciprocal. Now I know that you could just go ahead and divide by negative 4, but you don't want to have a denominator on this right side, so we're just going to multiply this whole thing by the reciprocal of negative 4, which would be negative 1/4, right? Multiply this side by the same thing, this cancels, so you have y plus 2, and that equals, now we don't really want to multiply this through, we just want to leave it as negative 1/4 times x minus 6 quantity squared. Okay? Then what we're going to do is we're going to move that plus 2 over to the other side and just make it a minus 2. And now we've got our y by itself. Y equals negative 1/4 x minus 6 squared minus 2. So the negative 1/4 is making it shrink. So this value right here, go ahead and write that over here, is making it shrink. So keep that in mind as you're starting to graph it. Go ahead and start by graphing the vertex. The vertex is at 6, negative 2, which would be right here, approximately. And then let's take our original parent function points, so 1, 1, and 2, 4, and let's multiply those, just the y value, by that negative 1/4. Okay, so in our 1, 1, that's now going to be at 1, negative 1/4, and our 2, 4 is now going to be at 2, negative 1. Okay, and we're graphing that from this vertex. So this vertex, we're going to go over 1 and we're going to go down 1/4. So it's just a little bit. Now remember, you are going to have a symmetrical point on the other side, so it's going to be over here. And then 2, negative 1, we'd have to go over 2. Now I can't because I'd go off the screen. So let me go back 2, and down negative 1, and there's going to be my second point, and it's going to have a symmetrical point over here, but I can't graph it. So you can see that it is going to be a compressed graph. That's about all I can draw because it goes off the screen. So it is going to be a compressed graph, but just remember that these points are coming from the vertex. Okay. Now my line of symmetry would be cutting it in half this way. The equation for that would be x equals 6. So here is the information that I need, and then there's my graph. Alright, so now let's do some examples of some parabolas that are opening to the left and to the right. Our first one is y squared equals 1/3 x plus 7. So the first thing that you're going to do is you're going to write down what your vertex is. Okay, my vertex, make sure you put the x value first. So my x value is negative 7. My y value is nothing, so it's going to be 0. So that's my vertex. Now, because the x value is the one that is not squared, then we know it's opening to the left or the right. But because this number is positive, then it's going to open to the right. Alright, so let's rearrange it and let's get this x value by itself. I'm going to totally turn it around, so I'm going to put 1/3 x plus 7 equals y squared. So we're going to multiply by the reciprocal. Reciprocal would be 3 over 1, which is just 3. That would cancel. So we have x plus 7 equals 3y squared. And then we're going to move that plus 7 to the other side and subtract it. So we have x equals 3y squared minus 7. Alright, so this 3 represents a stretch. It's a stretch horizontally. And again, we've already said that it opens to the right. So let's start with our vertex. Our vertex is negative 7, 0, which is completely off my graph. It would be right here. Okay. Now it's opening to the right. Now, when the original points for the parent function of the parabola that opens to the left or right, the ordered pairs are 1, 1, but it's the opposite, which would be 4, 2. So 1, 1, when I reverse it, it's still just 1, 1. So just remember that when it opens left or right, it's the opposite of the vertical points. So it's 1, 1, 4, 2. Now, we're still going to be multiplying, but this time we're going to be multiplying the x value because it is getting stretched horizontally. So we're going to multiply the x value by 3. Okay, so here we would have 3, 1, and here we would have 12, 2. Now remember, that's coming from the vertex. So we're going to move out 3 from the vertex. So 1, 2, 3, and up 1, and then there's the point. Now it's going to have a symmetrical point, which would be over here. And then we're going to count 12. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and up 2, and that would be my second point. And it's going to have a symmetrical point over here. So remember, when you count those points, they're not, those ordered pairs don't represent actual ordered pairs. It just represents the distance from the vertex. Okay? And so there's your graph. Okay, let's do one more example. This example is not in standard form, so that's going to be the first thing that you're going to do. So we're going to have to move this over to the other side. So we have y squared plus 2y, space, because we're going to complete the square, and another space, equals, when you move those over they change sign, so it's negative 3x and positive 5. Alright, so let's complete the square. Half of 2 is 1, square it, you get 1, so we're going to balance it with a minus 1, and then we're going to move that over and it's going to become a plus 1. Okay, so it would be y plus 1, quantity squared, equals negative 3x plus 6. And then you would want to factor out the coefficient, so y plus 1 squared equals negative 3 times x minus 2. Now here is my standard form equation, so that's going to give us our vertex. Our vertex is going to be 2, negative 1. Remember to take the x value first. And then because this negative 3 is negative and the x value is the one that's not being squared, it's either opening left or right, but because that value is negative, then it's going to open left. Now I just realized on that last example I didn't write down what the line of symmetry is, so when we're done with this problem we'll go back and we'll write what the line of symmetry is. Alright, now let's go ahead and rearrange it to get that x value by itself. So we're going to just completely turn this equation around. Negative 3 times x minus 2 equals y plus 1 quantity squared. We're going to multiply by the reciprocal. The reciprocal is a negative 1/3. Which is going to give us x minus 2 equals negative 1/3 times y plus 1 quantity squared. Then we're going to move that negative 2 over here and make that a plus 2. So we'll have x equals negative 1/3 y plus 1 quantity squared plus 2. Alright, so our ordered pairs 1, 1 and 4, 2, they're going to get multiplied by the negative 1/3. And remember that it is the x value that's getting multiplied. So we would have negative 1/3, 1, and we would have a negative 4/3, which would be 1 and 1/3, 2. Alright, so let's go ahead and graph those. Let's start with our vertex. The vertex is at 2, negative 1, which would be right here. And remember, we're counting from this point. So we would go negative 1/3, which is just a little bit to the left, and up 1. So it'd be approximately right here. And remember, you're going to have a symmetrical point on the other side. And then the other one would be negative 1 1/3 up 2. And again, a symmetrical point over here. So you can see that our parabola is going to look something like this. And our line of symmetry would be a horizontal line going through the vertex. And so it would be y equals -1. How about this? On the whisk, why don't you write down what the line of symmetry is for example 3, since I did not do that. Alright, so I hope this was helpful. I know I went really fast. We will have some time to practice when you come to class. Have a good evening.